Welcome back to the Save It for Parts channel. Today I'm starting a project that I've been meaning to do for quite a while, a mid-sized satellite dish aiming system. Now I've got this random collection of satellite antenna junk that I've been hoarding for the last few years, and I don't yet have an automatic way of aiming an antenna at a passing satellite. Mostly I've just been doing it by hand, which is fine, it works, but it's kind of tedious, it's error prone. If I drop the dish or trip or lose my arm strength holding a big dish over my head, that becomes a problem. Even the dishes that have their own kind of support structure are still a pain to move around to try to track the satellite, and I'd like to be able to do that with computer control. Now I've been able to do that just fine with the very small dishes, the tailgater, the carryout, that sort of thing. The problem with those is they are far too small to be useful for anything. They're designed for digital television signals, really strong satellite signals, and they're useless for anything else. What I really want to do is aim something like a big C-band dish, or even the 30-inch dish that works for L-band and some of the other frequencies I've been playing with. Now I do have some potential hardware here. I have the old pan tilt mount that we've used in a couple other videos. Now this one is pretty limited. It doesn't tilt up very far. It gives you a limited elevation range, so not entirely suitable for satellite work. I have another version of that, pan tilt mount, which I don't actually know as much about this one. I think it might have more elevation freedom, but I think it's a little weaker, so this one maybe not great for that big antenna. Now, one of my friends found a couple of these antenna rotors. So these are designed to rotate a TV antenna. They're a little bit older, but I think they do still work. And we even found a control box for it down at Axeman Surplus. This thing's kind of fun. Not very computer controlled. This is extremely analog, just a big clunky dial on the front. And I do have two rotors, so theoretically I could have one horizontal and one vertical, and there are some projects out there to do that. They seem to require a little bit of custom electronics work, maybe a little bit more than I'm familiar with. I also have a linear actuator, also from Axeman Surplus. This is one of the most expensive things I have actually bought for this satellite project. This was $75. So yeah, this costs more than probably the rest of this junk combined. And I still don't quite know how to use this yet. So this is on the drawing board, maybe for the C-band dish, but for now, I think I want to start a little bit smaller than that and work on that L-band 30-inch dish. So yet another camera mount that I have is that thing, a Pelco pan tilt mount. That is also from Axeman Surplus, but they just gave that to me. I walked in one day and the manager said, "Hey, we have this giant thing, nobody wants to buy it, do you want it?" And I said, "Yeah, sign me up for giant trash." I don't know what the exact model is, I can't find it on there, but I believe it's a pretty standard wiring setup. Most of these PTZ mounts use 24-volt AC. That's what my other ones use. And it's just 5 wires out, so I'm pretty sure there's a ground, up, right, left, down, and that's about it. The wiring here is already cut, so I'm going to just go ahead and strip that off and see if we can make the motor run. Okay, and that's the... Whoa. Almost knocked it off the desk here. Now I know I said this one wasn't quite strong enough for what I want, but you know, I could always put a counterweight on there to offset the weight of the dish, and I want to see what the elevation range on this guy is. Now, I've used this one before a little bit, and I've actually hacked into those 5 wires and put them onto an Ethernet plug. That way I can run it with my DIY CyberDeck system. This has a built-in pan tilt control, and that uses the same 24 volts in, and then we have 24 volt AC out with a RJ45 jack. I made sure to label that so we don't accidentally plug it into a computer or a network port, because that is the extra spicy Ethernet. Now I'm looking at this thing again, and there's a little screw-in plastic connector here, which matches, I think, something else I've been looking for and haven't been able to find. So I might rob this little part off this piece and use it for another project, because I don't think I'm going to be using that for anything at the moment. So let's dig around in that Pelco unit again. First I'm going to take the camera off. I have to say this camera housing is kind of neat. Yeah, it's a waterproof containment unit here for the camera. It's got a little power supply, some kind of lens control. Hey, there's another one of those 6-pin DIN connectors that I've been looking for. There's even a heater in there to keep the lens from fogging up. So this is kind of a nice enclosure for a camera. I don't really have a use for it at the moment, but yeah, we'll continue to hoard this somewhere else. Here's a tip out there for all you engineers, anyone who's going to be a future designer of electronics components or cars or anything really. Make it really easy to take apart and put back together. The business majors, the higher ups in the company are going to say, make it really hard to get it apart and together. Make it so we've got job security, so everything's proprietary, so you have to hire specialists to take it apart. No, don't do that. That just means your stuff's going to go in the landfill. No one's ever going to reuse it. If you make your products as simple as possible to take apart, put back together, there will be a huge aftermarket. You'll get a great reputation among the tinkering community, and I think in the long run, you'll have a better product. This is why I don't own any intact straight screwdrivers. They're all bent for some strange reason. All right, we got that off. So in here, it's remarkably clean. We have two of these big old AC motors. We have the gear assembly, and we do have some limit switches. We've got some here on this little shaft, and we've got some down below. Yeah, I think the vertical limit might be actually inside under this cover, so I might not have needed to open this up at all in the first place, but it's actually nice to see how clean it is in there, and it's nice to see how big and beefy these motors are, and this big spring. This makes me think it's going to be able to handle a pretty heavy load. And we do have our model number here, which was hidden underneath the camera. So this is a PT570 24P. The 24 probably means the voltage, and there it is, 24 volts, 48 watts. All right, so there are actual vertical limit settings, and yeah, these look very, very easy to adjust. It's just a screw, and we can slide that around this little ring here. So I'm really liking this thing so far. It looks very easy to adjust, very user serviceable. I have to say, so far the only potential downside of this Pelco is that it's really slow, but I think it's still going to be fast enough for most of the low Earth orbit satellites I'm tracking. All right, that is perfect. That is exactly what we want. Pretty much a full 180 degrees of vertical travel, elevation aiming. I think this Pelco unit is going to be what we want for the medium dish pointer. Okay, so next question, is this strong enough to move my little dish without a counterweight? And it looks like the answer is yes. Now I don't want this thing just sitting on the ground, so I've got a tripod mount for a satellite dish. This is actually a mount for one of these little domes, and this is another Axeman product, although they just gave me this one because it was the last one. Nobody was buying these things, and I was the only idiot who knew what this was for, so when I asked about it, they said just take it home. Axeman Surplus doesn't know it yet, but they're basically sponsoring this video. So let's see what's in here. This thing even comes with a carrying case and a free cardboard tube. I'm gonna make something dumb out of this. This wouldn't be the Save It for Parts channel without duct tape, zip ties, and hot glue. Is this all hacky and amateurish? Yes, absolutely. The tripod turns out to be a little bit wiggly here, so I don't know if I want to use this permanently for this dish mount, and I don't know if I want to use this dish mount permanently. All of this could change. Most of my projects are prototypes, they're temporary, they're tests. There's a ton of trial and error in this channel and in everything I do. So on the brain end of this, we have a few different options. I have a Raspberry Pi 3. I think this one works, although I don't remember what it was last used for. I have a couple different sensors. We have these USB position sensors that Marcus up at the CCERA in Canada sent to me. I'm hoping these will work, but I'm not 100% sure how to use them yet. I also have this little 3-axis accelerometer module. If the USB sensors don't work, then maybe this one will. I have a bunch of these relay modules, which should let me control the AC voltage from the Raspberry Pi's DC control circuit. There are some projects online using an Arduino Pro Micro for this project. I went to Axeman and I found an Arduino Micro. I don't quite know the difference between the Micro and the Pro Micro. Yes, once again, Axeman is unknowingly sponsoring this video, but I've been buying these there every time I go and I see them, and I don't know what to do with them. I don't know how to use an Arduino, but I have a couple of these kicking around. Gonna give this Arduino thing a try. We've got yet another fancy Axeman product. We've got the link sketch working on the Arduino, so I guess that's a good sign. So the Arduino code I'm trying to use is for the SARCnet Rotator Mark I from the School Amateur Radio Club Network. This is a group down in Australia who has designed this satellite tracking mount. It's mostly designed for directional Yagi antennas to hit Hamsats, to hit the repeater on the International Space Station. So it's not directly designed for a dish, and the original design here uses some special little motors and some custom enclosures and whatnot. I'm hoping that I can modify this enough to do a dish with it and use that PTZ mount instead of the motors that they're using. They have some helpful circuit diagrams, a bunch of walkthrough stuff, all of the code available, and they even have a version here that uses 2 antenna rotors, which is probably the most similar to what I'm doing. So this circuit diagram is essentially what I'm doing, except I'm replacing that directional antenna with a dish. I'm mounting the sensor somewhere on the dish, and then I'm going to use the security camera PTZ mount with its 2 motors instead of the azimuth and elevation rotor. Since this isn't quite the same board as in the examples, all the pins are slightly different, and I can't read a thing on here. I feel really old all of a sudden. Now, I could not find the Triac motor driver that they called for in the instructions that I'm following, so we just got this relay block, which seems to do the same thing. Okay, now we need to calibrate this thing. I'm going to see if I can do it correctly. I'm using this little piezoelectric buzzer, which does not seem to be working correctly. I'm starting to get my electronics enclosure put together with, again, more X-Men surplus parts. So now I need to make a long extension cable for the sensor so I can put it out on the antenna. Now in the old days I would twist all of my wires together and throw some electrical tape on there, but I've discovered the joy of soldering and heat shrink tubing. So yeah, this stuff seems a little higher class than just a massive electrical tape. Now, I still don't have the patience to actually be good at soldering, but this little clamp rig, which I think is also from X-Man, has made things a ton easier. Still can't see the markings on this dang little thing. Well, despite all my careful soldering and all my careful heat shrink, I've gotten the green and the red wire crossed in here somehow. All right, now that I've spent all morning making one stupid cable, I think I need to recalibrate the sensor again before I install stuff on the antenna. Now, of course, I just remembered I forgot a step. When I remade this cable, I forgot to put it through the little hole first. So now it won't fit through the hole in my enclosure, so I have to drill this bigger. Yeah, there's always something. Okay, now that we've theoretically got the sensor part of this working, we need to get the motor part connected. Now, you'd think after all my trouble with soldering that I would enjoy these little screw terminals, but I hate these things. I can never get a wire in there. Once it's in, I can never get it to stay in there. And this crummy imported relay block really isn't helping. It's theoretically rated to 250 volt AC, 10 amp, but these little screw terminals will only hold the tiniest gauge wire, so if you actually tried to run any amount of power through here, it would probably just catch on fire. So this relay board is basically all that came up on Amazon when I looked for that Aptinex Tricac thing. The Aptinex Tricac that the original project used for this doesn't seem to exist anymore. Nobody has it for sale. The company is out of stock, Amazon's out of stock, eBay doesn't have it. So I bought this relay board instead, but I didn't pay attention to the coil voltage. So it wants 24 volts DC to activate each of these relays. I'm trying to drive it with 5 volts from the Arduino, and the power light comes on. It actually tries to run the relays, but it's not getting enough juice to actually turn these on. So I need to get a 4-channel 5-volt relay board, or just 4 individual 5-volt relays, which I actually have left over from another Raspberry Pi project. So I think I'm going to rip out that board, put a bunch of these guys in, and see if that solves some of my issues. All right, I gave up on the King Dome tripod and reused a tripod from an old telescope. This one's a little sturdier, it wiggles a little bit less, and I don't have as many issues with the dish hitting parts of it as I did with that King Dome unit. So I'm hoping this will work a little better. And then we've got a slightly more legit mount for the electronics box. Now, I still have something wired wrong because my sensor wants to be rotated 90 degrees. It thinks that west is north. So we got to mess with that. And then I think I have my azimuth and elevation wires crossed here as well. Well, it's hunting a little bit here. It hasn't quite stabilized. So the problem with outside at the moment is it's super windy, and I don't know how well my little tripod's gonna hold up in this. This is too much wind for the little dish. I think we are going to have to wait for another day, and I'm gonna have to comb my hair at some point. Okay, move the sensor farther away from the pan tilt motor. I think that was throwing things off. So now it is pointing much closer to magnetic north. And yeah, I think, and it's not hunting anymore. So I think what was happening is the motors were driving, confusing the sensor with their magnetic field and causing it to wiggle back and forth. So that seems to have been taken care of. I should be able to send azimuth and elevation commands from a computer over to the Arduino, and it will rotate the dish. So let's go ahead and send it to 4545. I would just like to note that out of the many zip ties involved in this project, exactly one of them is doing what nature intended and holding a cable. So I was having a weird issue with Gpredict where it just refuses to update the TLEs for certain satellites. It was not showing me Oceansat, it was not showing me the latest Russian Meteor M23 and M24. I was going to use the CyberDeck here as my rotor controller, but I'm still struggling to get all the software on that one. So for now, we're just going to use the regular laptop. All right, we're going to give this a try with some actual satellites. Okay, Gpredict says it's driving the antenna right now, and I did hear some clicking, so... Okay, now we're actually getting something, although I'm pretty sure it's aiming in the wrong direction. So I've got the Hamlib rotor control daemon working. We've got it, we've told it it's a 202, an EasyComm model. I think that's the correct USB port. I can still manually control it from the Arduino IDE, just not getting anything from Gpredict for some reason. And my SAWbird filter is also having issues. I've got the bias T enabled here in SDR++, but the light is not on, so our bias T is not working. I guess that's just the exciting part of these SDR and satellite radio experiments. Nothing ever works the first time, or the second time, or the third time. It usually takes a week or two to get any of this stuff going properly. Okay, now it's doing something else. I have no idea what this thing is doing right now. And we've got a bunch of errors here in the rotor control window. And it seems like it's jumped USB ports again. It was on ACM1, now it's back on ACM0. Okay, well, I tried Meteor M23, and that's looking a little closer to correct. It wants to be at 16.8 azimuth, 0 elevation, and it drove itself over to, looks like it's hovering around 16.9 and 0.8, so at least it's at the correct starting position. I guess we'll see if it actually tracks the satellite once it comes up over the horizon. Yeah, I think it's actually tracking now. I don't know what I did, but it seems to be working. And I think we're getting a signal from Meteor M23. So this is pretty exciting. I finally have an automatic tracking mount. I don't have to just hold it myself. We're just running Satdump on that Meteor capture. Okay, we got some imagery. That's not bad. I've had worse handheld passes than that. I'll go ahead and throw these up as an overlay so you're not just looking at the screen. All right, next up is NOAA 19, so we'll give that one a try. Yeah, a couple minor issues here. It just did it again. It gets about 5 minutes in, and the Arduino and the serial port USB connection all reset themselves. So I have not yet gotten a full pass without having to go in here and restart stuff. Yeah, now we're just getting an error in Gpredict in the rotor control. So I think I have to unplug and replug everything in again. Okay, I screwed around with it a little bit more, and we did finally get a very nice, nearly full pass from NOAA 18. So here are a few of the images that satellite sent down. These are a little bit higher resolution than you get with the APT VHF channels. This is the LRPT L-band download. So basically the pictures are nicer quality, and we get a few different bandwidths. So we get thermal images, we get some of these microphysics bands, we get different stuff that weather forecasters can use to determine what's going on at different cloud altitudes, wind speeds, things like that. For me, these are just cool weather pictures, and I just think it's really cool to pull these live off of a passing satellite as it's taking the images. I went over to Axeman again and I got a bunch more electronics junk. I'm going to try and use some of these buttons for manual pointer control, and then I'm hoping to use one of these little LCD screens to display the current azimuth and elevation. And it seems like they will all need more free pins on the Arduino than I have available. I've used most of the GPIO pins running the sensor and running all those relays. Hi, Cat. Donnie is helping as usual. So I basically don't have enough free digital pins left over to drive one of these screens. Now I could probably drive the screen with a separate Arduino like this one, and then feed the azimuth and elevation data from the first Arduino to the second one. I'm not quite sure how to do that right now, so that might have to wait for a future version of this antenna aimer. So now we've got full manual control from right here on the panel, so if we need to adjust it more or differently than the computer control will do, I can just run it from these buttons. Now, of course, we can't forget one of the most important steps in this build, decoration. I was going to add some of these Arduino stickers to the blue box, but unfortunately they're so old they've just lost all their stick. Alright, well, so far this little dish pointer is doing basically everything I want. It can be computer controlled, it can track low Earth orbit satellites, it can be manually controlled for fine tuning, and it's getting a decent signal from a lot of those low Earth orbit satellites, so I'm pretty happy with that. And yeah, this is a good stepping stone on the way up to computer control for a bigger dish. And then of course this one will be in the toolbox for future satellite tracking and satellite decoding, and we'll probably do some more L-band stuff with this in the near future. I'd like to thank the folks at SARCnet for writing the code that I used to the Arduino system and for providing kind of a semi-step-by-step instructions for how to do stuff like this, even though I used a completely different motor system than they did. A lot of their information was really helpful, and I will throw the links to that website down in the description for anyone else who's interested in doing this. I didn't have to do nearly as much programming as I was afraid I'd have to do for this project. Now, I have some really fun ideas for this thing in the future. For one thing, I would like to modify my microwave imaging code that I wrote for the tailgater and the carryout dishes. That was really fun, but fairly limited because those dishes were only about 18 inches in diameter. This thing is 30 inches in diameter. Now that we have the computerized motor system, I can drive this around, have that scan through the sky, write that out to a bitmap, and hopefully use it as a radio telescope the way I was doing with some of those smaller dishes. That's going to have to be another project because I have to modify my code for this thing. I have to figure out how to interface with that EasyComm rotor system that the Arduino uses. Hopefully not too hard, but it's going to be a little more involved, so we're going to put that off for another video. Anyway, I'm going to wrap this one up and stop talking. Check out my other satellite dish videos, my other antenna builds, and all my other stupid projects. Thanks for watching, and we'll see you next time.